Welcome to the Welding Technology course, and the course code for Welding Technology is PR8592, and it's a professional elective subject for the regulation 2017. So here in this video lecture, we'll be seeing about the Unit 4, other welding processes. So in this other welding processes, we have thermite welding, atomic hydrogen welding, electron beam welding, laser beam welding, friction stir welding, underwater welding, welding automation in aerospace, nuclear, and surface transport vehicles. So introduction to other welding processes. Here we have this thermite welding. So thermite is nothing but a mixture of fine aluminum powder and iron oxide that produces a high temperature and combustion, and this is used in welding and for incendiary bombs. So thermite reaction involving aluminum is also called Goldsmith aluminothermic reaction. Usually this reaction is triggered by burning magnesium ribbon in presence of barium peroxide. So this is the setup for thermite welding, and here you have the you have a runner here and the riser, and this is the mold in which you have this the section that is to be welded is inside, and you have a thermite crucible on the top in which you will have this thermite aluminum powder and iron oxide mixture, and you have a tapping pin in this thermite crucible, and here you have a torch, welding torch, which is lighted for preheating this gate, and here you have this runner on the gate, and this thermite crucible, after this mixture has been melted, and it is once the tapping pin is removed, this molten metal is made to fall into this through this runner, and it's enter into this section to be welded inside the mold, and the extra this molten metal comes out through this riser, and the slag will be formed above this molten metal. And once this setup is completed, you will have all this various steps in making thermite weld here. So the first step involves here is you have this super hot steel. There's a slag is formed at the top, and once you remove the tapping device, this molten is poured into this through the through the gate, through the runner, and it's been filled in between this parts to be welded. And here you have the step 2, that's the super hot molten metal is made to fall into this gap in between, and extra slags formed is will be at the top of this molten metal, and sufficient time is allowed for this joint to form a strong one. And after cooling, and you can remove the molds, everything, and the proper grinding has been carried out to form a complete finish of the weldments. So the key terms used is thermite welding is a type of thermochemical welding, that is a fusion process. It is also known as exothermic welding or bonding, and it is used for welding heavy and large structures. It requires no electrodes and power supply. And normally the composition present by weight is 75% of iron oxide and 25% of fine aluminum powder, or fine aluminum powder and iron oxide should have the ratio of 1:3 by weight. So copper or chromium can be used instead of aluminum. Reactions. So that the superheated liquid, that is pouring metal, has temperature of 2500 degrees Celsius to 3000 degrees Celsius, And this reduced of ferric oxide by aluminum is exothermic, and therefore the iron formed will be in the molten state. And here the aluminum is chosen as a metal since it has strong affinity towards oxygen, and its oxide, aluminum trioxide, is highly exothermic compound. So the following reaction takes place. Fe2O3 plus 2Al gives Al2O3 plus 2Fe plus heat. And coming to the advantages and disadvantages, you have as advantages, you have very large size structures can be easily weld, no power supply and electrodes needed. And disadvantages, it's applicable to only ferrous metals, so the process is long and uneconomical. And the applications, it's used to weld very large works like joining of rails, pipes, broken teeth on large gears and large frameworks. And it is normally used for welding ferrous metals. So with this we come to an end to this thermite welding. So thank you and have a great day.